I didn't check. There we go.
Codec. Now the audio is much better. What's the microphone over here? Audio codec. Oh, ठीक है. Hey, 3 likes. 4 people watching, 3 likes. Ah, yes. Okay. How do I check my live video? There we go. Hey, 4 likes, 8 people watching? Wow, big crowd. My fan is going crazy in the video. Oh, yo, what's up? I think you can hear me now. Oh, still nothing. Did it not change? Still nothing? Still jet engine going? Ooh, noise. Should turn that off. Okay. How's the audio? Yee! 7 likes already. Woo! Woo! Hot. It's hot in here. Okay. Okay, what do we want to do today? He asks. Oh, 8 likes. That's a welcome committee was waiting for me. Okay. Let me organize my life a bit. Let's go to Zoom. Can I meet the CEO of Zoom? I want to slap him. Some things just don't work. Screen sharing now, everything's fine, people are ready. Okay, we want to talk about something. I'm being overwhelmed right now. I think I have too many likes. 14 likes already? Wow, 28 people watching. Am I Bilal Hamid? Yes, I am. Oh, did I put the wrong video? Oh, it's a live stream. I didn't put the name. That's why everyone showed up. Oh, I see. I see. 24 people watching. This is a O-level video, guys. Let me just write it down. I forgot to write it down in the name. O-level video. Welcome. Organic chem. Wow. Okay. And we're only 3 people just who want to study O-level chemistry. Okay. O-level chemistry. What are we talking about? Now, let's start with the reactivity series. What do you guys recall as a reactivity series? What is the reactivity? Sir, please reply to what? I'm not Bilal Amin. I guess. Reactivity series. How do we start the reactivity series? What do we have? Let's write that down. Let's get a better color. So you start with potassium, then you have sodium, then you have, what do you have? Calcium, then you have magnesium, then you have aluminum. What do you have? I don't remember my reactivity series. Should I open my notes now? This is dislike, because I don't know my reactivity series. Is that why I get a dislike? It's not on Noon Academy right now. Oh, zinc comes a little. Is it zinc? Let me write down zinc. What is it? Let me open my notes. I should have opened my notes before I started. My uncle came like 15 minutes ago, so I was with him. I didn't, open my books or anything, so sorry for that. But that's no excuse, is it? Electrolysis, worksheet. So much love. I'm getting so much love. I'm getting so much love. Okay, where's my reactivity series? Aluminum, then we have carbon. We have carbon, then we continue with our zinc, then we have iron, then we have tin and lead, not too important. Then we have what? Hydrogen, then we have copper, silver, gold. Check. This is our reactivity series. Now we looked at extraction of metals a few classes ago, where we were focusing on extraction. So the choice was that we were focusing on iron key extraction, but it applied to most metals, right? And how the issue with iron is, when naturally it's not found as iron in its pure form. It's found as iron 3 oxide, right? And how do you purify this? You can have it react with carbon and it undergoes reduction where it forms pure iron and carbon dioxide. And can we balance this out? If I put a 2 here, I can put a 3 here, I can put a 3 here then, and I put a 4 here. At this point I remember it, that's why I am fast at it. Okay, you can do this. Now you can do this as long as the metal is right after carbon in the reactivity series. Now there's an issue if there are metals before carbon, because carbon cannot be used to, displace the metal from its oxide. So we'll take aluminum into account. So this sort of reaction does not take place. If you have aluminum oxide, that's how aluminum is found naturally, reacts with carbon, this will not react. Because if you remember your, your displacement reactions for metals, the more reactive element can displace the less reactive one. Over here, carbon is the less reactive one, right? So it will not displace it. You guys follow? What are we doing? We're continuing with electrolysis. Are you the real Iron Man? Okay, so what do we do? What do we do? Well, we electrolyze it. Okay. Now the ore. Do you guys understand what an ore is? What's the ore for iron oxide? How do you get iron oxide? Thank you for correcting my name. I'm not gonna, guys, if you're not taking O levels, just, let people taking O levels focus. Should have highlighted this as an O level class. Okay. Hematite, yeah. So from hematite, you can get iron oxide. You can get iron oxide. Now the ore to get aluminum is called bauxite. These are the two ores they can ask you, and you can extract aluminum oxide from it. Okay. And a sort of emphasis on the process, much like iron, not just the chemistry is involved, a little bit of the process is also highlighted. Okay. And we're gonna look at our first use case for electrolysis. Why are you like this? First use case for electrolysis. It's kind of hot. I don't know where my Give me a minute. It's kind of hot. Sorry. Lol. Okay. So what happens is, so again, we're going to focus on the process this time around as well. So you extract bauxite, and bauxite is impurities plus, so bauxite is just impurities plus Al2O3. And once you have extracted bauxite from the earth, you have a mixture of impurities and aluminum oxide, and we don't care how exactly this is refined, but we can separate the impurities from the aluminum oxide and we can just have aluminum oxide. Okay. Now if you have aluminum oxide right now, what you do is you put it in a giant beaker. I say beaker, I mean container, but I'm going to draw a beaker anyway. And you fill it up with aluminum oxide. Can someone recall the color of aluminum oxide? Do you guys know? I think I spent a bit of time talking about the color of aluminum oxide when we were doing metals. Okay, this is filled with aluminum oxide. Then what I can do is put my 2 electrodes in there and pass it through a lot of electricity. Right, like that. Okay, what's gonna happen right now? Is it bauxite? Oh, that's an older question. Why do we have only 4 people here today? Call 1-5. Oh my god, I'm gonna start blocking people. Okay, YouTube is compromised today. My fault. Alright, what's gonna happen right now? Now, I haven't done anything to this aluminum oxide right now, so it's still at RTP. What do you think will happen right now? What do you think? Mesam Haya? Separation? Hey. It's still at RTP right now, so just yeah. Oh. Yeah, nothing right now. Okay, how do I disable the chat? It's just bothering me at this point. Nothing's gonna happen because it's an ionic substance. It's kind of like the same reason why sodium chloride as a solid will not conduct electricity. You heat it. You will heat it until it melts. Now the issue with heating aluminum oxide is it has a really high melting point. It melts at around 200 degrees Celsius. Okay. I'll just color these. And once it melts, then you can have a reaction taking place, right? Now you have the negative electrode here and the positive electrode here. What's gonna happen to each electrode? Now understand, we don't have to, there's no competition between ions right now. You only have 2 ions over here, which are aluminum 3 plus, and oxygen 2 minus. One of these will go to one side and the other one go to the other side. Which one's gonna go where? (2000), not 200. So a lot of heat is required to melt this. Ionic compounds will have very high melting points, right? Simple covalents will have melting points around 200 or lower. You know, they're generally weak, not weaker, but like easily meltable. Oh, just had coffee at 6:20. I don't think I'll be sleeping today. So, which one's gonna go where? Which one's gonna go where? O will go to the positive 1. Yep. O will go over here. And aluminum will go over here. And as soon as oxygen, let's zoom in a bit. Oxygen, let's get a better color as well. As soon as oxygen reaches here, this is filled with electrons. This is all filled with electrons, right? It's depleted of electrons, but this has extra electrons. Oxygen will give away its electrons and it will form 2 oxygen atoms, and those 2 oxygen atoms can, because they're unstable, will combine with each other to form an oxygen molecule. So to write that equation down, it's going to be O2 plus 2E, and you put a 2 here, right? That's the reaction that's going to happen on the anode. And over here, what's going to happen is aluminum, that's too thick. Did I not put a E over here? Aluminum with a 3 plus charge will gain 3 electrons and form aluminum metal. Okay. Now, can I ask what's gonna happen at the 2 electrodes visibly? If you had to describe what's gonna happen at the electrodes, what is gonna happen at the electrodes? Guys, bubbles of gas and silvery gray metal, you're more or less right. One thing is different though. This is at 200 degrees Celsius, so you probably won't see silvery gray metal, you'll probably see red hot molten metal, but essentially this. You're absolutely right. Okay. Now, this is how you get bauxite and you extract aluminum from it. Okay. Now, one thing you add, like, I don't think I've spent enough time berating, Cambridge examinations. So I'll do it one more time right now. They're stupid because right now they ask you to remember this one thing. Cryolite. Do you guys know what it does? Anyone, this is a revision. Do you know what it does? Cryolite. They add cryolite to this. You've never heard of it? Never heard of it? So what it does is you're just supposed to rectify it. It brings down, it makes it easier for you to melt bauxite or aluminum oxide over here. So it helps with that. So you add cryolite to it. So just that. Like, what is it? What do you need to know? Like, it just that. Right? Yeah, higher nose lowers the melting point of aluminum oxide. Good haya. Okay. Now this is, I drew it like this because you're more familiar with it, but you'll see it slightly more different, and you'll see why it's slightly more different when you actually see a diagram of it. And can someone tell me how it's different? How is it different? Absorb the diagram. How is it different? It could sodium aluminum fluoride as well instead of cryolite, right? That is cryolite. Sodium aluminum fluoride-ish thing. But cryolite is naturally formed, that's why you call it, oh my god, my mail's acting up. The products are leaving? Yes, products are leaving. If you notice, there's no classical way of arranging your cathodes and anodes. But what you notice is the anode is on top like this. This is your anode, and the cathode is over here. The container is actually the cathode. So what they do is the container, they remove this essentially, and they make sure that it's made out of a conductor, the vessel, and what they've essentially done is, the rearrangement is, they've just connected it here. So the entire bottom plate is negatively charged. So any aluminum formed will be formed here. And once it forms, it's a liquid, because aluminum has a melting point of around 700 degrees. So it's much more fluid than aluminum oxide, which is around 2000 degrees Celsius. So, and they put a hole over here, and the aluminum that's formed can flow right out. And this is what's happening here. That's the only difference. As complicated as this diagram looks, that's the only difference. You guys follow? Yeah, straightforward. Now, to me, every time I look at this diagram, I get nauseated and frightened of electrochemistry. It looks so terrifying, but it's essentially the same thing, the cathode being at the bottom, because it just, it's easier. Have you guys seen those, like, I think in physics you're told this, there's like a, you guys can see it, there's like if you want to coat the surface of metal, you have a spray gun with a charge on it, right? Spray gun with, like, you connect a battery to it, so those paint particles coming out have a charge on it, and the plate, what you're coating it with, is also connected to the same battery. So the charged paint spray droplets that are coming out also stick to it. Static electricity, right? You seen that? Something like that. Like, what you do is you take a battery and you connect one end to the metal you're painting it on and one to the spray, and that does the job. And essentially that's kind of something like what you're doing. Like, think of this as a, that crocodile clip for car batteries, the one I'm talking about, that thing, and that's attached to it. Essentially this. Maybe putting everything live on YouTube is an incredibly bad idea, because people just, I don't know. If there's one student on YouTube trying to study right now, I'm gonna slap a lot of people. Okay, does this make sense? How many of you think this is a really scary looking diagram, but once you see it like the crocodile clip thing, it makes a lot more sense? I'm sorry, I meant this is a very scary looking diagram. Right? Okay. What gas will be produced at the anode? Oxygen, absolutely right. Now hear my question out. I saw this in an exam, 2016, 2017. They asked, what other gas will be produced at the anode? Any guesses? Anyone saw the Snyder cut? Carbon dioxide. Exactly. You're saying, haha, I know? Your I know is for what? Because of the carbon electrolysis. Not only that, it's just at a very high temperature, right? Carbon itself will burn. Right? So I like that question. It was a very, we had to apply a bit of common sense to it. You know what I mean? You know what I mean? Yeah, you know what I mean? Yeah? 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 Who does the best yeah? Sir Bilal or me? I'm pretty sure he does it as well, right? I got it from him. Yeah? 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 I can't. Who does the better? Yeah. Yeah? Yeah? No one cares to answer. Okay, fine. Stupid question. Does this make sense? This is more or less it. Take him. Can I ask, let's go back to the reactivity series. If I had to extract sodium from its ore, whatever that is, which method will I choose for its extraction? Which method will I use for its extraction? Electrolysis, and the reason is? You what, mate? Am I? These are silly questions. Silly questions. Because it's more reactive than carbon, of course, obviously. Yeah, you guys get it. Now we have a third element which we'll talk about. It's electrolysis. We'll also talk about purification of copper. Now note how I'm saying purification of copper and not extraction of copper. Why do you think that's the case? Why am I calling it purification of copper and not extraction of copper? Purification of copper. Why is it called purification? My voice is really low. I'm so sorry. No one told me my voice was really low. Sometimes I have that problem. I don't speak into the microphone. Is it better now, Rania? Thank you for screaming your concerns, because I wouldn't have read it otherwise. Yes, my question is, why am I saying purification of copper and not extraction of copper? Any ideas? My peeps? What do you got? Ooh. I am blinding myself. It does not react? I guess you're on the right track, because copper is so unreactive, it's found naturally in its pure form. It's not an oxide. You don't find the oxide of it, right? Because it's so below in the reactivity series. I should just copy the reactivity series. I should copy this and bring it over here. Okay. Also, I don't like this white, so I'm gonna turn it to blue. Okay. So copper is naturally found, and the thing is, you're refining it, you're purifying it, and the way to do that is, let's make a beaker again one more time. Okay, I guess that's a bigger piece for a beaker, so let's make a smaller piece. Okay, this is my like a rock of impure copper. I pick it up, I put it in a beaker. Now the beaker is filled with something. It's just copper sulfate solution. Just ions containing copper sulfate. Okay, I dip it in there, and I'll do more. I'll dip it even more in there. And what I do is I take a pure rod of copper and I pick it up and I put it in there right next to it. And I should have done a better job picking it up. Okay. And what I do is I put my electrode on it, which is not made of copper, so I'll change the color, or just like pass current through it. Okay. And you see this has a positive charge now, and this has a negative charge now. And this is impure copper on the left hand side. Impure copper. It has sand and other metals rock off. It's just a, yeah. Okay, you're welcome, Rania. I got you covered, right? It's just impure with other metal particles in it and other things in it, and just dust and sand, like, Okay. We don't even know, I don't even know what it's called because we don't really, care. Okay. What's going to happen? What happens is the copper in it turns into copper 2+ ions, right? The solution is already copper sulfate. Could be other things as well, as long as it's not impeding our reaction. And if I were to write the equation of the anode, this is what it would be. The copper metal is giving away electrons and turning into copper 2+. I did that wrong. Okay. And at the cathode, what happens is these ions that are formed are attracted to the anode or cathode, and the reverse takes place. And the reverse takes place where the copper 2+ ions gain 2 electrons to form copper metal. So all the copper metal from it comes out and joins on this piece of copper metal. And what's going to happen over time is it's going to erode away. Whatever is underwater or in the liquid will get eaten off, And on the right hand side, what is going to happen is this is going to grow a lot, right? And it's going to be, all. Okay. What other things you might see over here is a lot of kachra forming at the bottom. And the word for this is called slag. We've heard that word before, right? It's just trash. But this is a poor use of the word trash because these contain not just sand and other debris, but also other precious metals like gold and silver, because they're all mixed together. And those are in their pure form as well, because they're also very unreactive. Minal, you're saying oxygen? Why? Yeah, so see, yeah, you're right. So what ends up happening is it doesn't go that far. And what ends up happening is copper comes out. This is a reaction where the electrodes are taking part in the reaction as opposed to not taking part. So before that happens, we just focus on the copper turning into 2+, and whatever copper is in the solution turns into copper metal. So if you had like a copper with an identifier chip on it, maybe that might come out from here and never get attracted over here. Because as soon as, even hours later, as soon as you turn off this switch, why am I putting a plus? If you turn it off, even hours later, there could be a chance that some atom from here, some copper atom from here is now an ion somewhere in the solution and never got attracted to this thing, because the copper always right next to it kept going over there, right? That could happen. I don't know if that's a big chance or it happens. No way of finding out anyway. But once you take it out, the copper solution remains the same. Maybe it has more debris in it now, more slag in it. So this is refining copper. Nothing has happened aside from you take a metal, you put it in there. Here's a question. It makes complete sense why you're taking this as the anode. Right? Because that's where the copper is coming from. Why does this also have to be copper as well? Why does this also have to be copper as well? Sir, where is your classes happening? I want to join. You can join us at Teaching Circle. Why does no, do we know the answer? You guys seem really tired or something. No one's talking. Are you guys upset at me for not taking classes? You guys, that's the reason, right? You guys are upset at me. SM, are you upset at me? Tired today? Everyone's tired today? I'm dying. SM's not upset? But what's going to happen? Why do I have copper? Why do I have copper? And why do I have one not working properly today? Oh, that's a shame. Because everyone's tired because of the mocks and whatnot. My brain isn't working either. I haven't slept in like 4 days now. Fun. I have to make solutions for my students. I'm going to have a live class and just do it there. I'm such a bad person. Okay, so at least just say, I don't know, like, don't be dead. Otherwise, the cathode would electrolyze. That's partly true, probably not. What's going to happen is the cathode has a negative charge. It won't take, it won't go into the solution, right? It's always more So it won't ever like go into the solution. It won't really electrolyze because you can see it's not electrolyzing, right? It's just gaining more. It's never losing. So not really. The reason why it's copper is because simple. You're adding more copper to it. Might as well add it to copper. If you add it to something like aluminum or something else, or carbon, you have to then scrape it out. And copper is a tough metal. It's really difficult to scrape it out. Why would you, So you start with copper and you like throw that, because it's all copper now. You don't have to clean it afterwards. It's all copper now. So you take this like club of copper and you throw it and you melt it and turn it into wires or something, whatever you want. Easy as that. Does that make sense? That's the only reason they're using copper. You could use anything you want, technically. Nothing's going to happen. But then you have to clean the copper out of it. Like, you'll have this thing, then you have to scrape the copper off. That's more work. Does that make sense? Thumbs up if you guys agree. Thumbs down if you disagree. Thumbs sideways if you get it. I don't get it. Mesam doesn't get it. Who wants to explain? Rida, why don't you explain to Mesam or to everyone? I don't know. You don't get it, Mesam? The idea is, if I had something else over here, let's make a copy of this. I copy this, I go to the next page, and I paste it here. Unashamedly. I paste it here, and I take the copper away, and I make sure it's still my, copper sulfate solution. Nothing has changed. But this time around, let's say I'm using an iron electrode. What's going to happen over here is copper will still deposit over here all around it. Right? Now the issue right now is, once I take it out, once I'm done with it, once I take it out, it's here. Right? Now someone has to have a job of separating this from the iron, take this stuff out, and not only that, it's welded together, right? It's going to be a tough job. Why would you do it? Just start with copper and you'll never go hungry again. Isn't that from the Lion King? Stick with me. Get it? Stick with me and you'll never go hungry again. Who says that? Who knows? Do you get it now? Do you get it now? Yeah. Yeah. Easy peasy. Japanesey. Who said that, by the way? Stick with me and you will never go hungry again. Probably bad voice impression. So we talked about purification of aluminum, extraction of aluminum. Then we talked about purification of copper. Now purification, not extraction of copper, because copper is already, extracted technically. It's not oxide. Then you have. Let's say I have a metal. Let's say I have a metal that is kind of reactive. Let's say, like, by reactive I mean up on the reactivity series. Now what's going to happen to it is it'll rust. So if I have a piece of metal, it's iron, it's going to rust. So in order to prevent that, I need to block its access to the air around it, because it reacts with air. What I can do is coat it. And what better to coat it with than a metal that's not reactive? So maybe I can take copper, maybe I can take gold, maybe I can take uranium. Probably not uranium. I don't know its reactivity series. ठीक है. like that. And the only difference between this and purification of copper is you're using both pure things right now, and you only run it for like a minute or so, and what's going to happen is this solution will lose gold, like this electrode will lose gold and coat everything on it. Notice how it's completely submerged, and it's all going to coat it with gold. As soon as it's coated with gold and it's the right amount of thickness of gold, you can bloop, take it out, and you're done. You have a gold plated watch or a pen or a iPhone. You go to the link Minal. There will be a sign up form in O-level chemistry under Bilal Hamid, and you can sign up there. ठीक है. Does that make sense? They'll ask you they're annoying. They'll ask you which electrodes need to have what charge, or which one has to be the cathode, which one has to be the anode. So the material you're getting coated has to be the cathode, and the material you want to, the material you want to use as the plating has to be on the anode. Because as soon as it loses electrons, it turns into aqueous ions, then back to there, right? Just check out a video on electroplating gold and whatnot. You can do it at home right now if you want. Yes, you can. Yes, you can. ठीक है. ठीक. Do you guys like my electrolysis notes? I spent like 40 hours on it. What do you guys think? Are they good notes? Yeah, I don't know what yes is on, maybe for this. Here's another way of looking at electroplating with better diagrams. You see the thing that needs to be coated has a negative charge, and the thing you want to use as the coating has a positive charge, because this goes there. Positive goes to the negative, right? That are great. That are really helpful. Yeah. You're welcome. What is galvanization? Galvanizing. We saw this in metals, and the idea is that it's essentially electroplating, but you galvanize the material which is also more reactive than the metal, right? So that metal on top will erode first, then the metal inside it. So cars are generally galvanized. Cars are galvanized. ठीक है. I think I said that so fast, no one got it. But the idea is either you can protect a metal by coating it with another metal that does not react, or remember, from metals you can stick a metal to it that is more reactive. Let's get a different color for a metal that's more reactive. So you stick another metal onto it that's more reactive. That's what they do to ships. So the main metal doesn't get reacted as soon as this metal, right? It'll only start reacting, this will only start reacting once this is all gone. So what you do is, if you have iron, you put magnesium on it, because magnesium is more reactive. And what you do is you keep changing it like disposable cartridges over time. You recall that, right? So galvanizing is the best of both worlds, where you take a more reactive metal and you coat the entire thing with it. I think the word is more confusing than the process. You coat the entire thing. Even if the metal eventually gets exposed, the outside of the metal, like let's say गाड़ी को dent पड़ गया and it just, यहाँ से गायब हो गया metal, this area. So this part of iron will still not rust because it's exposed to oxygen now, It will not rust because it's all surrounded, it's in contact with a more reactive metal. That entire metal has to first rust, then this part of the metal will rust. What did I say? Isn't electroplating there to prevent rusting? Why do you think we have chromium plated cars? Not only because it's shinier, it protects it. Electroplating is a form of protection. So either you can use something that's unreactive. The problem with unreactive metals, if you haven't noticed, is what? They're all frickin'ly expensive. Lol. So you could have a gold-plated car, but you're gonna pay through the nose for that gold-plated car. But other metals are cheap, and you can coat it. Like mostly it's iron that needs the protection, right? Because iron is mostly used everywhere. So you can coat it with magnesium or zinc, and you're happy. What say, Rida? Does that make sense? How do I look? He asked such a weird question. I'm so sleepy, I'm gonna fall asleep. I think we're all clear. We've wrapped up the chapter. Did you guys understand electrolysis easily? What do you guys want to do Monday? Do a new chapter or do practice questions for electrolysis? What do you want to do? Practice? We'll practice. ठीक है? Yes? Practice questions? Okay. Okay. Alright, so I'll see you guys Monday. Is cool? Is cool? By the way, I might have a moles question tomorrow. Not on this channel, but for my kids. You guys can watch it if you want. Oh, I'm not sure if I'll do it. I'll ask Bilal first what to do. ठीक है? ठीक है? ठीक है? Is that okay? Allah Hafiz? Shall we do the Allah Hafiz? You know, I found out, I was watching a trailer for a movie. Do you know what's better than a salute? Do you guys know what's better than a salute? Have you guys seen Qaidazam do a salute? Goes adab. Yeah. All right. I'll see you guys Monday. Or maybe you'll be with Sir Bilal. I don't know. Bye. Bye. Bye-bye, guys. Take care. Bye, YouTube. Thank you for that one dislike. Okay, I get that's just I was asking everyone. Okay, bye-bye. Bye, Massam. Bye-bye.